All right, Le Chatelier's principle states that when a change is applied to a system or stress is added to a system that is in equilibrium, like this one right here, the system will try to shift the equilibrium to undo that stress or relieve that change or stress. All right, so in a choice, yeah, I'm sorry, not choice. In part A, what happens if we lower the temperature? And because heat is written as a reactant, all we're saying is this is an endothermic reaction. This reaction requires heat, and that's going to absorb heat. That's a trademark of a endothermic reaction. So if we remove the heat or we lower the temperature, the system, which was at equilibrium, will try to increase the heat, right? In other words, it's going to favor the reactants. It's because it's going to try to undo that change that you just did to the system. All right, so this lowering the temperature is going to favor the reactants. B. What happened if we increase the pressure of the system? So this is a system possibly in a container, and pressure is caused by the collisions of gas particles with the walls of the container. So this only applies to gas particles. All right, so we're going to disregard this carbon because it's a solid. It's the pressure that it adds is negligible. Which side, the reactants or the products, has more moles or molecules of gases? Right, so here on the reactant side, we only have 1 mole of water, right, and that's going to produce 1 mole of carbon monoxide and 1 mole of hydrogen gas. So we have two moles on the product side versus the one on the reactant side of gases, right? So if we increase the pressure, how can the system relieve that pressure or decrease the pressure? It's going to favor the side that has fewer molecules, gas molecules. So again, it's going to favor the reactants. What happens if we decrease the amount of hydrogen? Hydrogen is a product. Oops, sorry, pen. Hydrogen is a product, so if you remove a product, the system that was at equilibrium will try to create more of the product that you removed. All right, so it's just going to favor the products. It's going to try to create more hydrogen until a new equilibrium is reached. Finally, increasing the concentration of water, adding more water vapor. The system which was at equilibrium, you're adding or increasing the concentration of a reactant. So it's going to try to get rid of that you just added and create more products. So it's going to favor the products.